All right, so what I'm doing here is I want to solve a couple problems similar to the homework so that you have an idea of just how to get started on them. As always, if you need to reach out to me, Remind is one of the easiest ways. Email is the second easiest way. So these are the two formulas we're going to be using. Ohm's law, which in this version, and again, you can't see it very well because I do not like this camera. I is equal to delta V over R. Let me get closer if that's going to work out better. Let's see here. About the same. And the power formula P, which is voltage times current. So in this case, it says determine the amount of electrical energy in joules used by the following devices. So there's three other ones, A, B, and D. I'm asking you to do. I'm going to do this one. So it says an Xbox video game player, and that uses 180 watts. Remember, 1 watt is equal to 1 joule per second. So that's useful, and it's if it's operated for 2 hours. So I'm going to say 180 joules per second. So I'll start. I'm basically using this for 2 hours, but there's 60 minutes in 1 hour and 60 seconds in every 1 minute. So there's 3,600 seconds in an hour times 2 hours is 7,200 seconds multiplied by that. So that's going to give me a total of actually I should show you that. So I've got something like this where I've got 180 times 2 times 60 squared. It's 1.296 million joules. So a joule is a tiny unit of energy. Usually in your home, you're charged by kilowatt hours. So this would be 0.18 kilowatts, and if you used it for 2 hours, 0.18 times 2 would be 0.36 kilowatt hours, and about 10 cents a kilowatt hour is what most electric companies charge. It's a little hard to say because they've got it split up into transmission costs and production costs and things like that. 10 cents, maybe a little bit more. All right, second one here, problem 29. Determine the equivalent resistance of a parallel arrangement of two resistors with resistance values of 5 and 9.2 ohms. So first thing I'm going to do is draw the picture. If it's in parallel, I've got one resistor there, one resistor there. I'm not asking you to figure out current here, so I don't really care if there's a power source here or not. I can draw one if you want. That would be a positive and that would be a negative. The power source isn't going to affect the resistance of these. So this is going to be 5.0 ohms, 9.2 ohms. In order to solve for total resistance here, in parallel, 1 over the resistance in parallel is going to equal 1 over R1 plus 1 over R2. So in this case, 1 over the total parallel resistance, 1 over 5 plus 1 over 9.2. So when I do that in the calculator, I do 5, the inverse button, so that's 1 over 5, plus 9.2, the inverse button, so that's 1 over 9.2, equals. So when I get this, I get 1 over the parallel resistance is equal to 0.3086. So that doesn't give me my resistance that I want, it gives me 1 over the resistance. So I've got to flip this again and use the reciprocal button again here. When I do that, I get that. Also, you could set this up probably to cross multiply it if you think of this as being over 1. So here, the parallel resistance is equal to 3.24. So the big idea with this and other parallel circuits is that as you add branches in a parallel circuit, the total resistance actually goes down. So if you notice, this total resistance is less than the least resistive branch. So there's no way, no matter how many other branches you add, you could ever get a total resistance of a parallel circuit of more than 5 ohms. In fact, it's less than that, 3.24. Okay, I'm going to do the next one and the final example. So in this case, I've got a parallel circuit over here. It's got 2 resistors. It's got a 12-volt power source, so I'll write that down. 6.4 ohms for R1, and 3.9 ohms for R2. First thing, determine the equivalent resistance. That's exactly what we just did. So it's a parallel circuit, so 1 over Rp equals 1 over 6.4 plus 1 over 3.9. So I'll put those in the calculator. 6.4, and that's 1 over 6.4 plus 3.9. I'll flip that, so that's 1 over 3.9 equals that. So I'm going to flip that again. And that means that the total resistance is equal to 2.42 ohms. And again, that's the circuit right there. Determine the current in each branch. Well, the key thing to remember is that voltage in a parallel circuit is the same across each branch. Why? Well, voltage is energy per charge. So when you have charges leave this power source here, they either go through the left side or through the right side. A single charge would not go through both. So that means that this is the only spot on the circuit for the charges that take this path where there's resistance, and that's the only spot they'd use voltage up to overcome that resistance. So this would be 12 volts across here, also 12 volts across here. So no matter which path a charge would take, it would use up all 12 volts across the resistor. So to find out the current through R1, so I'll call that current number 1, that's the voltage across R1 divided by R1. And in fact, what that is going to be 12 volts over 6.4 ohms. 1.88-ish. The current through second resistor, 12 volts, 3.9 ohms. Divided by 3.9, that's 3.08 amps. So the total current that the battery produces in this circuit would simply be those two added together, because I've got 1.88 amps going through this, 3.08 amps going through that. Hopefully it makes sense. You've got less current going through the branch with more resistance, more current going through the branch with less resistance. So when I'm trying to figure out the total current in a parallel circuit, you just add up the current in each branch. So this is 1.88 amps plus 3.08 amps. Let's see if I can do that in my head. 3 plus 1.88 is 4.88. Plus 0.08, it should be 4.96. My way of double checking this, and I could do this a different way, is to figure out the voltage divided by the total resistance. Well, I got that earlier, 2.42 ohms. So if I try that now, 12 volts divided by 2.42 ohms, I better get something pretty similar to 4.96 amps within rounding. 12 divided by 2.42. That's 4.96 amps. So that says that I did it right. So you can use either method here.